Now I want to take a second to show you problems related to restriction enzymes, plasmids, and restriction sites. These can be simple problems, but not if you haven't seen them before and practiced them before. So here I have a plasmid, and you can see that oftentimes they're going to indicate how long in base pairs this piece of DNA is. So this one is 5,400 base pairs long. So it's a pretty small segment of DNA. The first question says, how many segments are produced if the plasmid is treated with indel and HIND3, which are two different types of restriction enzymes. If you want, hit pause and see if you can figure out this answer before we go through it. Remember, restriction enzymes will recognize a restriction site, and the restriction sites are labeled for you here. So this is telling you that HIND is going to cut right here. So if we treat it with, let's do this first one, we'll call it indel. So here's restriction site. So this restriction enzyme is going to cut the plasmid here, here, here. And if we treat it with HIND, it's going to cut here, here, and that's it. So now we have to count up how many pieces of DNA would we have floating around after we treat this plasmid with restriction enzymes. Well, here's one piece right here. So here's one piece, here's another piece, two pieces, 3, 4, and all that would be 5. So your answer would be 5. Now I race to answer the next question because it's about that same plasmid. So example 2 says, identify how many segments are produced and the approximate length of each segment in base pairs if the plasmid was cut with HIND3. So we're going to treat it, and the restriction sites are here and here. Now if you think about it, this looks like about, from here to here, would be about 25% of the plasmid. And this segment ends up making up about 75% of the plasmid. So the answer to the first part of the question is we would end up with 2 segments of DNA. And to figure out the length and base pairs of this segment, we would have to take the total number of base pairs, times it by 75% or 0.75. And to figure out the length of this segment of DNA, it would be, again, take the whole and times it by 25%. This would give you about 4,050 base pairs long. So that's this segment. Let's indicate that. So this segment would be about 4050. And this segment would be about 1,350 base pairs long. So that would be this one right here. Let's look at a different type of problem now. Example 3 says, when plasmid B is cut with different restriction enzymes, the following fragment lengths are produced. This table is showing you that if we cut with this restriction enzyme, then we're going to end up with 2 pieces of DNA. If you cut with BAM, then you only end up with 1 long piece of DNA. And then if you put both of them in there with that DNA, we would end up with 3 different segments. So with this information, they want us to show on this plasmid where the different restriction sites are for both the ECO-R1 and the BAM restriction enzymes. They also want us to indicate the lengths and base pairs of each of the segments of the plasmids. First of all, you can tell from here and from here the length of our plasmid. Our plasmid is 1,000 base pairs long. First, I'm going to start with ECO. So it says that if I treat this plasmid with ECO-R1, that it's going to cut in 2 places, and one segment will be 400 base pairs and the other one's going to be 600. So let's say that we cut here, and I'm just going to draw an imaginary line here that I'm going to erase here in a second. But if we cut here and the other restriction site was here, does that make sense that this segment would be 500 and this segment would be 500 base pairs long? So we know this is not right for this other restriction site. So I always like, again, to cut basically at 12 o'clock and then figure out where the other restriction site's going to be. And I believe it would probably be about, let's say, here. So this segment would be the one that's 600 base pairs long. And this segment would be 400 base pairs long. And we would want to label these restriction sites if it asks us to do that. And basically, we're just labeling it with the restriction enzyme. So this is a restriction site for EcoR1. And this is a restriction site right here as well for EcoR1. But we're not done yet because they want the restriction sites for EcoR1 and for BAM. So now we have to figure out where BAM cuts. And I can tell that BAM only cuts in one spot. There's only one restriction site. So I'm just going to add this information down here. So we know that this was a restriction site for EcoR1 and here as well. So put EcoR1. And let's figure out where BAM is cutting. Now you have to look at this third column to figure out where BAM is cutting at. If you notice, I have a segment here that is 400. And then these two segments, they add up to 600. So I bet the restriction site is somewhere on this segment that was 600 base pairs long. So if there's a restriction site here for BAM, then I should get, when treated with both restriction enzymes, I should get a segment that is 100, a segment that is 400, and a segment that is 500. Let me show you, though, that there can be different answers, both correct, for this problem. Because if you think about it, I cut with Eco here and here. Remember this segment right here, this one was 600. If I have a restriction site here for BAM, it would still give me the same results. So let's put Eco here, BAM here, and this would be 100, this would be 500, and then this one would be 400 base pairs long. So these types of questions, sometimes they can take you a while, but they're pretty easy to do. But if you have not practiced them, then you will not be able to finish them in the time constraints of the test. Now this next problem, make sure that you understand how to read a gel electrophoresis, and that's coming up in another lecture. So I'm introducing a little bit about gel electrophoresis here with this plasmid question. So what this gel is showing us is that if you cut DNA with EcoR1, then it's going to cut it into two segments. And this segment is 70, see this over here, is 70 kilobases long, and this one is 30. So you're just using the gel electrophoresis to help you figure out how long these different segments are. This one would be 60, this one's 40 in length, and then when you treat the DNA with both restriction enzymes, you get a 40, a 30, a 20, and a 10. So this first part says, how many restriction sites were on the plasmid for the restriction enzyme EcoR1? So it's a plasmid. Make sure you pay attention to whether it's a plasmid or linear DNA, because you would get two different answers. So if you have a plasmid, then you would have to cut, here's one cut, and that would just give you one piece of DNA. It'd just be one long piece of DNA. There has to be a second restriction site. So the answer to this is there's two restriction sites, and that would give you one piece of DNA, and here's the other piece of DNA. Now, I want to show you if it was linear DNA, so if we were cutting like eukaryotic cell linear DNA, and you would only need one restriction site. If you cut here, you would get two pieces. Does that make sense? So cutting linear DNA is going to end up with different pieces than cutting circular DNA that has the same number of restriction sites. So let's go down here, and it says, on the following plasmid, sketch the approximate locations of restriction sites for EcoR1. Indicate the length of each segment in kilobases. Again, hit pause if you want and try to answer the question and see if it matches what I'm going to get here. First, we should probably note that this plasmid is 100 kilobases, or kilobase pairs long. And I always like to cut at 12 o'clock. And think about if I cut at 12 o'clock and 6 o'clock, then those segments would be 50 base pairs long, or 50 kilobases long. But I need 70 and 30, so I'm going to cut about right here. So that means this segment would be 70 kilobase pairs, and this one would be 30. On this plasmid, it wants us to put all the restriction sites. So for eco and for the other restriction enzyme, which is hay. So again, let's put our restriction sites on there for eco. We determined they were there. Got to label them. I'm not going to put 70 and 30 on there because I'm going to cut with the other one, with hay. And going over here to this third column, we can see that when you cut with both of them, we're going to end up with 4 pieces. And right away, my brain is picking up that I could take this 30 segment. Remember this segment right here was 30? And I could split it into 20 and 10. And I can take the 70 and I can split it into 40 and 30. So let's do that first cut. Let's take 70 and split it into 40 and 30. Remember, the whole thing is 100. So splitting it at the 6th position would give you 50. So we need to go to 40. So I would say 40 is probably about here. So that means this segment is going to be 40 kilobase pairs long. This one would be 30. And now we have to cut the 30 into a 20 and a 10. So again, you can cut different places. I mean, I'm going to go ahead and just cut it here. And this is my segment that is 10. And then this one is 20. But I also could have cut it here, making that bigger piece 20 and this little piece right here, the 10. But let me get rid of that so you're not confused. Now we just need to indicate that the restriction site for hay was there and also here.